everyone. Let us start today the equality and types of matrices. So we have already discussed about the equality of matrix, that if the matrix Aij and Bij have the same order, then matrix Aij is equal to Bij. We have got it. Now there are four properties of equality. Number one is determinative. Two matrices A and B, either A is equal to B or A is not equal to B. Then reflexive. For any matrix A is equal to A. And symmetric matrix. If A is equal to B, then B is equal to A. In that case, it is the symmetric matrix. And transitive. If A is equal to B, B is equal to C, then A is equal to C. This is transitive properties of matrix. Now there are various types of matrices that we come across. So we will discuss one by one. So first is row matrix. We also call it row vector. Suppose it is elements are 1, 2, 3. It is 1 by 3 matrix. Order is 1 by 3. And so it is called row matrix or row vector. Then column matrix. Suppose 1, 2, 3 in the form of a column. It is 3 by 1 order. So it is also known as column vector. Then rectangular matrix. See, rectangular matrix, the the number of rows and number of columns are not same. Here, 3 columns are there and 2 rows. So 2 rows, 3 columns. So order is 2 by 3. So it is a rectangular matrix. So when their order is same, suppose it is a 3 by 3 matrix, 1, 3, 4, 5, 2, 4 and 1, 9, 6. See, it is the square matrix. In zero matrix, all elements are zeros. Then diagonal matrix. So only there are elements, some values in diagonal. They are not equal. And above and below the diagonal, all other elements are zeros. That is called diagonal element. Matrix. And scalar matrix, same with diagonal matrix, but the diagonal element is same. There 2, 2, 2. Here it was 2, 3, 1, 2, 3. It is not equal, but here in scalar matrix, diagonal elements are equal. Then another one is unit matrix, or sometimes we call it, often we call it, it is an identity matrix. That diagonal element is 1, 1, 1, and all other elements are zeros. And symmetric matrix. So this is common. We come across. The transpose of the matrix becomes the original matrix. The transpose means will come later on when we will study different operations of matrices. So how transposition is done, then columns will become rows and rows will become columns. So if we transpose it, it becomes the original. Suppose this is the original matrix, matrix A. Now if we transpose it, it becomes the original matrix itself. We can see it. Then skew symmetric matrix. That if we transpose it, it becomes negative. So these are the elements. Suppose these are the elements. So if we transpose it, you will find that original matrix becomes negative. Then horizontal matrix, the rows are less than the number of columns. Here 4 columns are here, only 2 rows, so it is a horizontal matrix. Then vertical matrix, just reverse of this, that it has 4 rows and 2 columns, so it is a vertical matrix. Now upper triangular matrix. In upper triangular matrix, the above the diagonal some positive elements are there, but below the diagonal there is no elements, all are zeros. Below that is all are zeros, above this some elements are there. So this is upper triangular matrix. And opposite this is the lower triangular matrix. This time the elements towards the right of the diagonal are zeros, and towards left or below all are positive elements. So